All right, folks, can you hear me? We're back. Sorry about that. Yeah, so a transformer exploded down the street and I lost power. Um, so yeah, that was fun. I My power went out and yeah, my power went out and I lost internet and power and everything there for a hot minute. So can you all see me and hear me now? Yeah, I actually heard the transformer explode. Like the power went out and I heard a big bang. And luckily luckily the power came back. So if you're still waiting for me to come back, um, refresh the stream. I am live again. Yeah. So gotta love power outages, random power outages. It's a little bit windy and rainy outside, so maybe that was it. Oh my goodness, RDT, thank you so much for the sub. I appreciate that. Thank you for subbing amidst the chaos, RDT. And I apologize if I missed any other follows or anything while I went offline. Um, but yes, thank you so much, RDT. Good to have you here for the chaos of this whole thing. I appreciate you, RDT. All right, but I think we're back up and running. Sorry about that, folks. Yeah, I heard the big bang from somewhere down the street of, yeah, I don't know if, I hope somebody didn't hit the transformer. I imagine, the wind just knocked something down or whatever. Chaos, I know. Hey, we roll with it. Null says, not sure where you're located, but we just received a high wind advisory in Indiana. Oh my goodness. Wow. Yeah, the weather's been like really squirrely today. There's a bunch of birds. I have a tree right outside my window, and I can actually see there's like a bunch of birds just sitting there staring at me. They're not flying around. They're just like hunkering down in this tree, but they're all like looking straight at me. It's kind of funny. Yeah, the weather's been wild today because it was like, 60 degrees Fahrenheit yesterday, which is absolutely bizarre for January, and now the temperature's plunging again. Yeah. Okay, but we're back. Thank you for sticking with me there, folks. Sorry about that. All right, let's keep going here. So we were just talking about sockets, and sockets are the thing that provide essentially a two-way connection. So I kind of like to think of it like a tin can on a string. Um, like you have one tin can, there's a string, and then it connects to another tin can that your neighbor has. So you got the string stretched between the second story windows in your houses. You've each got a tin can, and the string stretches between them. But how do you know who's allowed to talk when? Who should talk first? Otherwise, you're just going to be talking over each other into your tin cans, and nobody's going to be able to hear the other person. Um, and you need to know when you should be listening. You got to say over, right? Exactly. So maybe you say over, maybe you use, walkie-talkie CB radio protocols to know when you can talk and when somebody else is talking. And that could be called a protocol. So it's a set of precise rules that determine who's to go first, what they are to do, and then what the responses are to that message, etc. All right. Welcome to the stream there, Dr. Chuck 42. Your username does not match the username of the real Dr. Chuck, so I can't confirm whether or not you are him, but I do know that that is not his username. He's actually joined the stream in the past. So could be you, maybe not, but I don't. I can't really confirm at the moment. But if it is you, it's good to see you again. Oh, okay, good. Yeah, so Dr. Chuck is back, it looks like. Welcome back, Dr. Chuck. They used to be CC4E. Yes, that's correct. I've had some folks come in here, trying to impersonate other people. So just double checking. Pardon my skepticism. But yes, welcome back, Dr. Chuck. It's great to see you. Dr. Chuck is the author of this course, Python for Everybody. So great to have you here, Dr. Chuck. And we are just getting into web scraping with Beautiful Soup, which is part I'm really excited about. And also recovering from a random power outage that completely borked my stream there for a little bit. So we're just kind of coming back now. So you're joining at a good time. We just came back from a power outage. I just had to restart the stream. But yes, good to have you back, Dr. Chuck. Also, too, if you're enjoying this course so far, please say thank you to Dr. Chuck. Grant says there's a streamer I follow who had a period of such strong skepticism that his catchphrase was, "Are you a bot?" Yeah, I mean, hey, it happens, right? And Dr. Chuck, also, you missed it, but we started the stream. Oh my goodness, thank you so much for the sub, Dr. Chuck. And my alert worked. That's great. Thank you so much for the sub, Dr. Chuck. Oh, and I need to return on stream closed captioning. Those were on, and then they got turned off when my computer restarted. Okay, we're back. I'm glad you like the emotes, Dr. Chuck. But yeah, we started this stream with a quiz on regular expressions, and we passed it the first time. So yes, 100% first try. Yes. So I'm pretty proud of that. All right, let's get back to where we were here. Okay, here we go. So we were talking about protocols. And yes, that is the topic for today. Cactus Jack, welcome to the stream. The topic for today is web scraping and just general sort of web networking protocols. So when you type HTTP in front of a web URL, what does that actually mean? What does HTTP do? What does it do for us? And as we've seen, it stands for Hypertext Transfer Protocol. And we were just talking about what a protocol is. Dr. Chuck's enjoying the emotes he gets now as a subscriber. All right, so a protocol essentially, like we were just talking about, it's a set of precise rules that determine who gets to talk and when. And there's a bunch of documentation around these protocols, of course. If you really want to read what those are, you can go to the w3.org site on protocols. If that's something that really floats your boat, you can do that. We're not going to do that, but you can. And if you want to read 176 pages on network protocols, you can as well. But if you take a look around, page 36, we'll find the syntax for the GET request. Now, if you are familiar with web development, as many folks who are on the stream right now are, you know what a GET request is, right? It essentially does a fetch, right? You're fetching from, you're saying, all right, hey, I want to go and get some information from this API or this web location. I want to get some information. What are some other examples that you all might know of? What are some other examples of types of requests that we could make? So for example, maybe you have built a full stack application that's contacting an API. What are some other types of requests that we can make to that API? Or maybe you're writing information to a database. What are some other types of requests we could make? CRUD, yeah, so CRUD standing for create, read, update, and delete. Those are sort of the general types, but let's say we're using JavaScript. What are some other types of requests we might make? Instinct says post, yep. Yeah, we could do a post where we're essentially saying, all right, I have some data maybe from a form, and I want to maybe write that into a database. So I want to send that information. I want to do the create part of CRUD where I want to create maybe a new record with that form data. So I would do maybe a post request. Yeah, what are some other types? Yeah, we could do a put, delete, yeah. And then there's maybe some more exotic ones like, patch, that type of thing. Yeah. And all those types of things they're part of that protocol, right? They're specific types of requests that mean a specific thing that help us tell the recipient, hey, this is what I'm trying to do. This is what I want out of this interaction. And so our GETs, are going to request a document from a web server. And then we make a connection on a specific port. And then we send a line of data saying, hey, this is what I want out of this interaction. I want to get something. Crayon says, not familiar with these types of things, but isn't there also sort of is this connection still a live signal? Yeah, like sort of like a ping that you can send at regular intervals to say, hey, are you still there? Yeah. So in this case, this is what we want out of the interaction. And then this is where the information is that we're requesting. Oh, sorry, here. This is where the information is that we're requesting. And then we also send a blank line. The web server will respond with some header information about the document and a blank line followed by the document content. Yeah, so we're going to get back not only the content we requested, but then also kind of some metadata about the information we're getting back. Instinct says, so sockets are like real-time CRUD. Yeah, and essentially, so like I mentioned a couple months ago, we made a real-time chat app. With JavaScript, we said, all right, I want to make something that would allow me, like, like AOL Instant Messenger or Facebook chat or whatever, that would say, hey, if I want to send messages to somebody in real time, how do I do that? And we did it with WebSockets, with literally what we're talking about right now, sending information back and forth in real time and saying, like, hey, I'm going to send you a message. It's going to say, hey, I've received the message. And then the person on the other end says, I'm going to send you a message now. So let's look at the world's simplest web browser. Perhaps the easiest way to show how HTTP protocol works is to write a very simple Python program that makes a connection to a web server and follows the rules of the HTTP protocol to request a document and display what the server sends back. All right, so let's look at this first. We're going to import, excuse me, we're going to import the socket package here. We're going to define our socket first. Then we're going to connect to the resource that we want. In this case, it's data.pr4e.org. And this is the port here. So port 80. And then we're saying, all right, what message do we want to send? What is our request? Well, we want to do a GET request to this location. And then using HTTP protocol. And it looks like here we're kind of setting up like the blank line maybe. And then encoding it. And then we're going to call the send command or the send method. So on our socket, we're going to send this information. And then we essentially have a while loop here. We essentially have a while loop here that's going to keep that information, that's going to keep this connection open. So while this is true, if the data we're getting back is less than 1, or if the length of the data we're getting back is less than 1, then we break. So we break out of this loop. Otherwise, we want to go ahead and print the data we're retrieving. So essentially, we don't want to close the connection before we've essentially received that data. But once the data is done, then we go ahead and break, and then we close the connection. All right, so let's double check let's see whether that interpretation is correct. And Crayon says the only situation where one sock is enough. Yeah. So first we make a connection to port 80 on the server. And then we send our request. And then this sort of sequence here signifies an end of line. And it's like the equivalent of a blank line. This is kind of a visual interpretation of what's happening here. Once we send the blank line, we write a loop that receives data in 512 character chunks from the socket and prints the data out until there is no more data to read. Yeah, so exactly. We're going to keep this loop open. It's going to keep looping and printing 512 characters at a time until there's no more data to print, and then it's going to break. So what do we get back? Well, we get back first some metadata, right? We get back this kind of header data. And you've probably seen this before in JavaScript too. It's the same thing. It's a protocol, right? So you've seen something like this before where we get a bunch of, we can see a bunch of header metadata about, the request we're making to an API. We don't normally look at that, but we could see it if we wanted to. And sometimes we have to customize our own headers too when we're sending requests. Hey, Anna, good to have you here. They say, where do you learn? This is Python for everyone. You can do ! Project in chat, and that will give you a link to this course. It's 100% free, really great. That's what we're looking at right now. All right, so this is all header data here, but then down here, we actually get our content. So the majority of what we've gotten back is header data. Of course, Anna, good to have you here. So the output starts with headers, which the web server sends to describe the document. And, content type, what type of document is it, etc. It adds a blank line after the headers, and then we actually get the content of the file. All right, so I'm curious. Let's see if we can actually do this in VS Code, just as is. I don't know if this will work or not, but let's give it a try. So I'm going to create a new file here. I'm going to say, we'll call it, what should we call it? Simple HTTP. We'll copy this. Oops, hang on. Oh, that's the result. I want to actually grab the script. All right, try again. Drop that in, save it, and we'll just see if we can run this. So we'll say simple. Oh. Simple http.py. Hey, check it out. It worked. That's pretty cool. So we just made basically a GET request with Python directly in the terminal via Python. And Dr. Chuck says, "Woo!" Are you happy we're stress testing your course? No, that is neat. I'm used to making these types of requests via basically a JavaScript backend, right? Via a JavaScript API or server or whatever. And so it is pretty neat to, essentially do the same thing with just a few lines of Python, in a non-live instance. Sorry, my dog is choosing to be very loud. Bud, can you lie down, please? I'm glad it works, Dr. Chuck. Yeah. All right, so that's neat. That's a very cool way to make that kind of request. And sometimes I can see how it would be helpful to just, even if I am building a JavaScript application, to not have to build out all that infrastructure first, and to just kind of be able to make the raw request and just say, hey, is this working? Can I hit this API? Without even having to use something like Postman to kind of set up the framework that way. I can just code the request super quickly in Python and be like, hey, is this API going to give me what I expect? Or is this endpoint am I going to be able to interact with this endpoint in the way I'm expecting to, before I build out all the JavaScript to do all the fancy stuff? All right, so let's go back down to where we were. Yeah, okay. Crayon says, is requesting in 512 character chunks there as an example amount, or are there specific amounts you should specify? That's a great question. It hasn't told us yet, but let's see. Yeah. Okay, well, here's an example. So check this out. So down here, the receiver is set to 5,120. So it looks like we can specify different amounts, and without having to specify specifically 520. It doesn't seem like 520 would be a requirement, just given that web data can come in all different sizes. But in this case, it's specified to 5,120. And we can see what happens if we don't specify an amount either, right? Let's try that really quickly. Let's not put anything in there, and let's see what happens. So do this, save it, and let's just run it again. The best way to figure this stuff out is just by trying it, right? Sometimes. And then we look at the documentation. Okay, so yes, so we need to put some kind of an argument in here. So the error is telling us that we need at least one argument, and we have not given any. So in this case, 512 is not required, but we need to put something there. Yeah, so let's see if this is mentioned later, and if not, we'll go look at the documentation and we'll see, what we're supposed to specify specifically, if there is something specific we should put in there. Shakespeare says, Romeo and Juliet is such a good example text. Even people who don't like Shakespeare can dig Romeo and Juliet. Yeah, I mean, I think so too. I think school does a pretty good job of making Shakespeare very boring when it really isn't. I didn't get into Hamlet until I saw the David Tennant Royal Shakespeare Company production of Hamlet, and since then I've gotten into a lot of Shakespeare. It's a lot more fun than school makes it out to be. Okay, So this example that we just did shows us how to make a low-level network connection with sockets. And we can communicate with a web server, with a mail server. Mail servers definitely, sending messages back and forth, all other kinds of servers. It's pretty wild if you ever read about the history of email and the way email works now. Like, email is redonkulous with like how convoluted and wild its protocols are. It's pretty wild. I read an article of somebody who tried to make their own like email client, and it was an adventure. All that's needed is to find the document which describes the protocol and writes the code to send and receive the data according to the protocol. However, since the protocol that we use most commonly is the HTTP web protocol, Python has a special library specifically designed to support the HTTP protocol for the retrieval of documents and data over the web. One of the requirements for using the HTTP protocol is the need to send and receive data as bytes objects instead of strings. In the preceding example, the encode and decode methods convert strings into bytes and back again. The next example uses this B quote quote notation to specify that a variable should be stored as a bytes object. So encode and B quote quote are equivalent. All right, so in this case, what we're doing here is we're encoding the string hello world as bytes. And we can do the same thing by calling the encode method on the string. So I guess whichever one is, clearer, or whichever one is your standard practice, I would probably suggest that you might want to pick one and stick with it. But either one would work. Dr. Chuck says, I like Easter eggs and I cannot lie. Yeah, definitely. The Monty Python references. All right, so not only, just like we know, from using JavaScript to interact with APIs and things, we can send, text and images over HTTP as well. So we got a plain text file, which had new lines in the file, and we simply copied the data to the screen as the program ran. We can use a similar program to retrieve an image using HTTP. Hey, Dave, good to see you. Crayon says, was it mentioned in the course the name Python is a Monty Python reference? Yes, I believe it was mentioned in the first chapter of the text. Yeah. All right, so we had new lines in the file. We simply copied the data to the stream. We can copy an image. Instead of copying the data to the screen as the program runs, we can accumulate the data in a string, trim off the headers, and then save the image data to a file as follows. Okay, so we're going to, again, import the socket package, also import the time package. We're going to define our host and our port. We're going to define our socket. We're going to connect to that socket. And then we're going to take that socket and we're going to call the sendAll method here to send our formatted request. So encoded as bytes, we're going to send our GET request, define a count variable, and then a picture variable as an empty sort of bytes object here. So as before, we're going to have a loop here. Our connection is going to stay open while we're still receiving data. We're going to retrieve all the data. This is, a large amount here. As soon as we're done receiving the data, we're going to break that and then close the connection. We are going to sleep for, I don't know what 0.25 is. I'm sure it'll tell us, maybe a quarter of a second. And then we are going to count the length of our data. We're going to print that. And then we're going to store the, essentially we're going to keep accumulating the data for our picture until we have it all. So essentially it's going to, what this is doing here is it's kind of a running total, right? We're saying, all right, take the data and add it to any existing data and keep going through this loop until we retrieved all the data, and then we close the connection. Yeah, sleep takes an amount of seconds. Yeah, that seemed to make the most sense here. Yep. So quarter second, sleep. So after we close our connection, we're essentially going to trim the header data. So we're going to look for the end of the header because we know that the end of the header is always going to have two CRLFs. Now, does anybody know what that means? What does CRLF mean? Yeah, exactly. In this case, CRLF stands for carriage return line feed, which essentially just means two blank lines. It comes from the days of typewriters and teletypes, before some of us were born. Not everybody, but yes, carriage return line feed essentially refers to the blank lines at the end of the header. So we're going to find that. We know it's always going to be there. We're going to print the length of the header. And then we're essentially going to say, grab the, essentially we're going to say, all right, just grab that header data and print it. Yeah. And then we're going to skip past the header. And we're going to save that picture information to a file and then close the file. So kind of going back to, when we were learning how to open and close files, we're going to open it, write the data, and then close it. If it doesn't exist, I believe it will also create it. Jacksbeard says, my name is Eric, and when I was a kid, my friends' older siblings often called me half a bee. I have no idea what that meant for many years. Oh yeah, Eric the half a bee. Yeah. Null says it's remarked out. And so in this case, this line is the only thing that's commented out. So the rest of this will run. So this is the only line that's commented out, just describing what's happening. The rest of these lines will run. So when it runs, we should see this. Oh no, time dot sleep line. Oh yeah, I see. I didn't notice that at first. Yeah, so it is commented out. So the sleep is. All right, maybe it'll say something about that in the description. And we're going to do that. We are going to do this one too. So what is going to happen here? Well, as it's going to loop through, and we're going to print the data length. It's going to keep printing, the amount of data until we've captured all of it. It's going to get the header length and print that. So we've printed the header here. And then it's going to write the data to the file and save it. So notice here, that the content type of this file, where is that? Oh, here, yeah. It's not a text file, right? We're used to seeing, text files and that type of thing, especially when you're interacting with APIs. You're mostly going to be getting objects, text, that kind of thing. In this case, our content type is actually an image. And then once the program completes, we can view the image data by opening the file stuff.jpg in the image viewer. So we'll do that in just a minute. As the program runs, we can see that we don't get 5,120 characters each time we call the receive method. We get as many characters as have been transferred across the network to us by the web server at the moment we call receive. In this example, we either get as few as 3,200 characters each time we request, up to 5,120 characters. Yeah, so that 5,120 is the maximum. It may not be what we get every time, right? It may not be what we get every time, but it is the maximum we're expecting. Depending on the speed of the transfer or whatever, a lot of different factors, right? We could get, none potentially. Your results may be different depending on your network speed. So if you run this, and I highly recommend that you do, if you run this, then you might not get the same amount of characters on each line that I do. So the last call to receive, we get 3,167 bytes, which is the end, and then we get 0 after that. So we call close. We can slow down our receive calls by uncommenting the call to time.sleep. So we can wait a quarter of a second after each call so that the server can get ahead of us, as it were, and send more data to make sure that we're always getting the maximum. With the delay in place, the program executes as followed. So we're getting pure doubles of 5,120 each time, because we're giving the server some time to build up that data. And it is kind of interesting, speaking of using sleep and stuff like that, sometimes you'll find that websites will use, wait or sleep or whatever, strategically to make you think that more is being done. There'll be a spinny, like a spinny icon or something to be like, we're building your request, we're calculating your tax return, all that type of thing. When really the calculation is done, It's just a psychological tactic. It's just a psychological tactic to either make you think that the task is more complicated than it is, or to kind of hedge for slow network connections and making sure that everything is really ready before it gives you the result. So there's various reasons why you could use that, but I think the most common tactic that you see is, we need to make this thing seem complicated or really hard to calculate, and so we're going to, wait 5 seconds before we show you the result. All right. There's a buffer between the server making send requests and our application making receive requests. When we run the program with a delay in place, at some point the server might fill up the buffer in the socket and be forced to pause until our program starts to empty the buffer. The pausing of either the sending application or the receiving application is called flow control. So you can kind of think of it almost like, maybe like two people picking apples. Like one person is picking apples off the tree and putting them in a basket, and then the other person is taking the apples out of the basket, or taking the full baskets and dumping them into a truck or something like that. And so how do you control the speed of both parties to make sure that the basket is always full when it's being taken from, but that it doesn't get so full that the person picking those apples has to actually pause and lose the flow of their action? So that's kind of flow control, right? Is how do you coordinate two parties, one sending and one receiving, so that you have the maximum data flow between them. All right, now enough talk. Let's actually try this. Let's see what we get. So again, we're going to create a file here. Move this over. Let's see, do I already have a stuff? I don't already have a stuff.jpg, I don't think. All right, so I've just copied the code here. Move this over a little bit. There we go. Hey, Milan. Welcome to the stream. You're wanting help with your high school project. That's awesome that you're learning Python in high school. That's really cool. I wish I would have learned Python in high school. I'm not going to help you do your homework, I'm afraid. But there are lots of online resources that can help you, especially something like Python for Everyone here. You need a program in Python that generates unlimited primes. You need to generate the first 1 million primes in 10 seconds or less. Wow. Okay. Well, there's, hey, if you're really, out there bent on asking for help out there, someone else in chat, you're welcome to help offline. It is an interesting challenge. I like it. It's interesting. We aren't going to do it here, but if someone else in chat wants to help, they are welcome to do so. I wish I'd learned Python in high school. That's awesome. Just make sure you're actually learning it. So don't go out there looking for somebody to just give you the answer. Hopefully someone's willing to just kind of sit down with you and talk through the program so you actually learn the material. All right, let's run this. Okay, let's see what we got. All right, so we got the header data. Yep, and you can see here that, yeah, we didn't get the full, like, 5-1. Oh, thank you so much for the follow. Yeah, we should get a new file too, right? We're gonna look at that in a second too. My feed isn't working. My follower and subscriber feed is not showing up. Let's see if I did see the follow there. I didn't catch your name. Sorry, because I can't see my events now after I had to restart the stream. Oh, congratulations, Milan. You did it even better. Did it in 2 seconds. Awesome. Used a different header so it didn't count. It's not like homework. It's like bonus points, work you don't need to do. That's awesome. Yeah, congratulations. So you've already done the problem. That's great. Good job. Yeah, if anybody in chat has any suggestions on how they can do it again with that particular header that they specified, feel free to work that out with them. Okay, so we've printed out our header here, got the length, all that information. Now let's see if we got that file written to this location with that image in it. Let's see. Yeah, look at that. We got our image in our location here. So we've got stuff.jpg image now stored in this file location. Hey, check it out. If you can see that, let's see. There it is. It's the cover for the written text of Python for Everybody. Exploring data in Python 3. Awesome possum. Okay, so we not only made a text request, we also were able to strip the image out of it. We not only made a GET request, we were able to strip apart the header data and the content and then save that content to a specific file location on our machine. And then, parse that data into an image. So very neat. Okay. We don't need to run this again with the increased length. We could do that if we wanted to, but the actual thing works just fine. Awesome. But yeah, also, and Milan too. Also, congratulations on learning Python in high school. Like I said, I mean, that's going to be hugely beneficial for you. And, I'm learning Python now and I'm in my 30s. And so I wish I would have learned Python, when I was 16, 17, 18. That would have been great. Would have put me so much farther ahead in general. Just any coding. I didn't learn any coding in high school and I wish I would have. I didn't even have the chance. So it's awesome that you have the chance. Okay. All right. So we've done a couple of successful requests. We've gotten text. We've retrieved images. While we can manually send and receive data over HTTP using the socket library, there's a much simpler way to perform this common task in Python using the URL lib library, or URL lib. Using this package, we can treat a web page much like a file. You simply indicate which web page you would like to retrieve, and URL lib handles all the HTTP protocol and header details. Ooh, that's nice. All right, so how would this look with the romeo.txt file from the web using URL lib as follows? Dan says, retrieving web pages. Are we going full beautiful soup soon? We are today. Scrape the web, become the web. I know, this is what I've been looking forward to this entire time. I think the whole reason I started this course was so that I could learn web scraping. I'm pumped. All right, so how do we make this even simpler than it already was? Well, we import URL lib.request, and then we set up our request by saying, hey, this is the URL I want to hit. And assuming we're going to be retrieving some text here, which we are, we're going to then just take the response and we are going to parse it just like we would a regular text file, right? We're going to open it and then we're going to print each line, decoding it from byte format into strings and stripping the any extra white space. All right, so let's try that. Ooh, that was loud. Thank you so much for the cheer. I appreciate that. Hassan, good to have you here. Welcome to the stream. Yeah, my feed isn't working. After I had to restart my stream, my follows and subscribe feed isn't working, so I have to kind of like squint at what you all are seeing in the pop-ups on your stream or on your screen. But I think I'm going to try to catch them all. Okay, so let's try this. Take this, pull this over so y'all can see. Oh, and then go do this. There we go. All right, awesome. So we don't have to deal with any of the, manually stripping out the headers or anything like that. What this package is doing for us is it's essentially saying, all right, it's going to handle the nitty gritty of the request We just have to pass in the resource we're trying to retrieve, and then it's going to retrieve it for us, strip off the headers, and then we can choose what we want to do with that resource. Yeah, right? That was awesome, wasn't it? Yeah, this is very cool. I really like this a lot. This is fun. Um, so once we've opened that web page, we can treat it like a file and read through it using a for loop, just like we would a regular text file. So when the program runs, we see only the output of the contents of the file. The headers are still sent, but our code, ooh, thank you so much, Dan. Thanks for the cheer. We see only the output for the contents of the file. The headers are still sent, but the code consumes the headers and only returns the data to us. Yeah, so it's a much cleaner way of doing it. So if you've taken the 100 Devs web development course, it's kind of like how before we learned how to use, before we learn how to use like Node and Express, right? Or before we learn how to use Express, essentially. The first exercise that you do is essentially building out an API without Express. And you have to build everything manually. You have to manually use Node and handle all the requests and everything. And it's something you can do. It's perfectly possible to do it. Oh my goodness, thank you so much for the sub, Dan. But there are ways to make it easier, right? So once you understand what's happening under the hood, then there's nothing wrong with using things, other tools, other packages, libraries to streamline that process, right? So that's kind of what we're doing here. We learn the nitty gritty, what's happening under the hood, and then we say, okay, how do we make that go away? How do we get past that hump so we don't have to do that every time? In this case, it's using this URL lib package here. Thank you so much for the sub, Dan. I appreciate that. Always love having you here. Thanks for the sub. Oh my goodness. Yes. You've subscribed to 7 months. Holy cannoli, Dan. Thank you so much. That's so generous of you. Wow. Absolutely not required, but thank you so much. Dan says, learn the thing to automate the thing so you never have to do the thing. It's a weird job. It is. And that's what I love about it, is that there's so many different ways you can approach any given problem. And sometimes you can automate it so the problem no longer exists. I'm going to give you another recognition here because it was so very kind of you, Dan. Thank you. Okay, so now that we've learned how to make these requests in a more streamlined way, we can actually get down to the nitty gritty of parsing the actual content of that we got back, right? What the body of that request, the stuff we're interested in, we can handle it like we have been this whole time using loops and regex and, extracting bits of the text and that type of thing. So we can write a program to retrieve the data for romeo.txt and compute the frequency of each word, just like we've done before with the plain text file. All right, so we're importing a couple of different elements here. The ability to make those requests, the ability to parse, and then error handling. Also very important whenever you're working with external data sources is that you're appropriately handling your errors, right? Whether that's using like a try catch block, try except block, whatever you want to call it. What do we do if that resource doesn't work the way we expect? Because we have no control over it. All right, so we're going to make a request to this URL. We're going to set up our count. And then we're going to loop through it. We're going to decode each line from byte format to string format. And then what are we doing here? What is split doing? We're calling split with no arguments. What is that doing? Chat. It's been a while since I've asked you all a question. Need to see whether anybody's still alive out there. What is split doing? Null says it's separating each word. How do we know that it's going to separate each word when we call split? How do we know that that's what it's going to do? Genetic memory. Icefire says splitting at spaces by default. Yeah, that's correct. So the default of this method is that if we call it without passing in any specific arguments, it's going to just split on spaces by default. So for us, that's the easiest thing to do. If we have a line of words, then we can assume they're separated by spaces, and so we can just call split. Now, we could pass in something if we have, let's say, a file that's separated by commas, which is very common too. We could say, all right, instead, I want you to split on commas, or I want you to split on double quotes, or I want you to split on, I don't know, dashes, right? There's various different ways we could separate a file, but, if we're just dealing with regular text, split is probably a pretty safe choice. Now, also another review question here. How does Python know what a line is? How does Python, when we say for line in fhand, we aren't defining a line anywhere. How does Python know what a line even is? What does Python recognize as a line? Yeah, Maiva, it's suspicious. So in this case, Python is looking for the /new line character specifically. So in a line of text, you're going to have these hidden characters /n, which essentially mean new line. And so it's going to define a line as, okay, hey, I've hit this new line character. That is what I'm going to call a line. And so that's how Python is defining a line in our file. Yeah. Dan says, what does decode do here? Well, in this case, what we're getting out of this is essentially byte data. And so we need to call decode to convert it back into a string. So we're taking each line and we're saying, all right, turn it back into a string and then split it on spaces. Yeah, and that was touched on briefly a little bit farther up here, but good to look at it again. So here, we send and receive data as bytes objects instead of strings. So encode and decode is used to convert it to bytes and into strings and back again. Okay. All right, so in this case, we're grabbing that information, splitting it on spaces, and then for each word in our list here, we're going to say, essentially, we're going to keep a running total of the frequency of each word. So a kind of a histogram of, hey, for each individual unique word in this file, we're going to grab the count and keep a running total of each one. Oh, glorious bytes. Yeah. Hey, Dami, welcome to the stream. Dami says, is it ASCII decoding? I don't know for sure. We're going to cover ASCII a little bit later in this chapter. I just know it's converting from bytes to strings and back, but I'm sure there's multiple. I know there's multiple types of encoding and decoding that you can be doing. You can be doing ASCII, UTF, Unicode, etc. So that's a good question, actually. And I think we're going to get to that a little bit later in the chapter if you'd like to stick around. Because, yeah, you could have ASCII, Unicode, other languages, etc. Yeah, that's a good question. So let's put a pin in that for now, and we will get to that later. Yeah. Yeah, and that would be my guess too, Dan, is that we're looking at UTF-8, but we shouldn't assume, right? All right, we got to run this one. We haven't done this one yet. So let's take this, and I'm just going to replace the existing contents of this file here. A little more complex now. We're actually analyzing the data we're retrieving. So do this, and we're going to run it again. Let's see what we get. Yeah, so, I didn't save it. Hang on. I was like, wait, that's not right. Run it again. There we go. Okay, so what do we get? Right, we get a dictionary with the word frequency of each unique word in the text. So you can see like the word is occurs 3 times, the occurs 3 times, etc. So we've already done that exercise on a flat text file, but this is essentially just adding the element of we're making a request to a web source instead. Alrighty, let's see, we still got a few minutes before the break, so let's go on to the next section here. But soft, what light? Practically poetry. Yeah, literally poetry, in fact. So how do we look at binary files using URL-lib? So sometimes we want to retrieve a non-text or binary file, such as an image or video file. The data in these files is generally not useful to print out, but you can easily make a copy of a URL to a local file on your hard disk using URL-lib. The pattern is to open the URL and use read to download the entire document into a string variable and then write that information to a local file. So earlier we saw how we could, take an image and download it into a file. Now let's see how we can do that with URL-lib as well. So what are we going to do here? Well, let's look at the difference. So we're going to say, all right, make a request to this particular URL and read its contents. So call the read method on it. So how does that compare to what we did before? Well, previously we just opened the URL. Now we're opening the URL and reading the contents. Okay, so what's the difference there? Let's pause for just a second because it's a kind of an important distinction, right? The difference here is that when we're looking at this plain text file, we're really not doing anything with it until we start looping through each line in the file. We're just saying, all right, this information is available for us to use. We have a connection to it, but we haven't done anything with it yet. We don't start really looking at it until we're actually looping through each individual line, right? But here, instead of just saying, all right, this is available, you can start looking at it. Here, what we're doing is we're essentially downloading the entire document first thing, immediately into a variable. So rather than just saying, hey, this is ready for you when you want it, we're saying, nope, we want it all right now. Save it in this variable here. So that's kind of the difference. It reads all the data at once rather than waiting for us to loop through each portion of it when we need it. So now the next thing we're going to do is we're going to say, okay, let's create this new file, write the data to it, and then close it. And here we're specifying this WB is saying, hey, this is a binary file for writing only. So write, and this is something that we haven't touched on in a while. So when we first talked about working with files, you don't have to specify the second argument. You don't have to specify the second argument, but you can. And in this case, the second argument is specifying, hey, we want to write to this file because it's brand new. There's nothing to read from it. We want to write to this file, and we're going to be writing binary data to it. Okay? So important distinction there. Normally, if we're calling open, right, we might be saying, all right, I want to open a text file and I want to read data from it. But here we're specifying we want to write data to it in binary format. So let's try that. Let's see. I'm going to run out of file names here. URL lib.py. Oh, and I think someone asked earlier too, I didn't answer this question. I think somebody asked earlier, hey, what about the code runner extension that you have installed in your VS Code? Couldn't you use that? And the answer is yes. I could, run it with this handy dandy little extension that I have. For me though, it's good to kind of rehearse these commands and how to run things sort of raw in the terminal. But it's personal preference, right? We have these tools, we can use them. I'm just choosing not to, just to build muscle memory on how to actually, do this stuff by hand. Oops, I'm gonna do py. There we go. Image url.py, url.py. Okay. All right, let's see if that worked. Yeah, it did. So it created the image file. It saved it in the current location. And there we go. There it is. Hooray. Go us. Okay. If this is a large audio or video file, the program may crash or at least run extremely slowly when your computer runs out of memory. Yeah. And that was a thing that when we first learned about handling files, right? That was a thing that the text cautioned us against, is that you don't necessarily always want to read the entire contents of the file, especially if it's a very large file. And you might be saying, well, that would have to be a huge, huge text file to make you run out of memory on your computer. And I will tell you that's absolutely possible. I mean, some text files, depending on what data you're looking at, they can get huge, right? They can be massive. And so, you got to be careful about using read. So in order to avoid running out of memory, we can retrieve the data in blocks and then write each block to the disk before retrieving the next block. That way the program can read any size file without using up all the memory you have on your computer. And that's again why I paused and made that distinction between the way we first looked at that text file and read each individual line versus calling the read method and reading all the data at once, is that maybe that's not always the best choice. So instead, we're going to handle it kind of like we did the text file. We're going to say, all right, let's just open the URL and connect to that resource. We haven't read anything yet. And the same thing here. We're just going to say, all right, now I'm going to create my target. So I'm connecting to my source. I'm creating my target, and then I'm going to loop through and read the data a chunk at a time and write it to the file. So I'm going to transfer it in chunks rather than trying to get everything all at once and store it in memory, especially if it's something like a video file, right? That could be disastrous. And so instead, we're just going to read the data in chunks until we're done and then close. Yeah. Fuel says another thing to consider is that if you develop a web app, that web app might have a limited amount of memory, and you might get many requests to read files, and then cause the web server to run out of memory and crash. Yeah, that's a great point. You might be overtaxing the source too, right? If you build something and you're going to have a bunch of people accessing at once, if you try to give everybody who accesses that data, everything all at once, it might be too much for your source resource. So you could overtax it. Instead, if you break it into chunks, you're managing that data flow. Kind of what we talked about before, managing the data flow. So we can write it in chunks instead. And we're going to read only 100,000 characters at a time and then write those to the file before retrieving the next set of characters. So let's try that. So I'm going to delete this. Okay, and then we're going to just replace this existing content with this safer version. And save it and run it again. There we go. So we can see it's telling us how many characters were copied, and we should see the image is back and it looks just the same. So really no, functional difference, right? Just a safer way of transferring that data. Crayon says, okay, starting to make more sense to get in chunks now. Yeah. And the first thing when I read this, how this was being done here, I was like, I think I remember the text cautioning us against doing that, even with text files, because it could just have disastrous consequences for a variety of reasons. All right, now we're going to get to the good stuff, folks. It's time. How do we use Python to scrape the web? So web scraping is when we write a program that pretends to be a web browser and retrieves pages and then examines the data in those pages looking for patterns. That's what I want to do. As an example, a search engine such as Google will look at the source of one web page and extract the links to other pages and retrieve those pages, extracting links, and so on. Using this technique, Google spiders its way through nearly all the pages on the web. Google also uses the frequency of links from pages it finds to a particular page as one measure of how important a page is and how high the page should appear in its search results. I will say that, this is kind of how Google used to work back in the day, is it would, sort of crawl through the link rings and and look at frequency of how often a page was accessed or how often other sites were accessing that page in order to build its search rankings. Now, as we know, Google uses a pretty much completely esoteric and arbitrary, page ranking, depending on a lot of different factors. Not necessarily one thing or another. Nobody really knows how the algorithm works. I'm not sure Google even knows how the algorithm works anymore. And it's much more complicated. But in the good old days when the internet made sense, this is really how Google would figure out what to show in its search results. It would crawl the web and spider its way through the web to figure out what to show. Hey Sangi, good to see you. Ghibli says, who knew reading could be so dangerous? Yeah, 100%. Books are dangerous. They're filled with ideas. The Google algorithm is money. Yeah, pretty much. So much for don't be evil, right? Alrighty, so we can retrieve this HTML and then we can use our friend regex to parse it. This is what I'm planning to do. So one simple way to parse HTML is to use regex to repeatedly search for and extract substrings in a particular pattern. So we all know what HTML looks like, right? It's just data in tags. But if we want to just retrieve the information from those tags, we can use regex to pull out specific text. So in the simple web page here, we can construct some regex to match and extract just the link values from the text as follows. So we can say, all right, out of this, I just want this link right here. So we're going to say, all right, match on the value of HTTP or HTTPS, right? It could be either one because we don't necessarily know if we're dealing with a secure or non-secure link. And so this is going to look for href, HTTP, or HTTPS, followed by one or more characters. Followed by colon / / followed by one or more characters, and then followed by another double quote. So the question mark behind the S indicates the search for the string HTTP, followed by 0 or 1 S. So it may or may not have the S after the HTTP. The question mark added to this, so down back this part here, indicates that the match is to be done in a non-greedy fashion instead of a greedy fashion. So we kind of saw that earlier when we took the quiz on regex, is if we want it to stop at the smallest possible matching string, we can use this question mark to say, hey, you're done, stop, no need to try to find any additional matches. Crayon says, I think it's easy to forget what a huge difference Google has made to the way we navigate the internet. Yeah, does anybody remember, like, before Google was big, like web rings? You know, how on everybody's personal web pages, they would have, at the bottom, they would have a web ring of, like, related websites, or their favorite websites, and that's where you were supposed to go next. Yeah, it was great. I remember those in the early days of the web. You have everybody would have their little link trees or their web rings at the bottom of their site and visitor counters. It was fun. I miss it. Alrighty. So we add parentheses to our regular expression to indicate which part of our matched string we would like to extract, and then we produce the following program. Okay, so we're importing sort of some of the same packages we have before. We are also importing regular expressions, and we're also importing SSL. Now, I believe this stands for Secure Socket Layer. And with this, essentially, this is what's going to allow us to access HTTPS, so secure websites, instead of just the raw HTTP sites we were looking at before, right? So with this, we can say, all right, I want to be able to access secure sites as well. We can ignore SSL certificate errors. I'm sure we've all seen that sometimes. We input a URL. We open the URL and read all the contents. And then we look into that, into the contents of our HTML. And we find all possible links on this web page. So essentially, what we're retrieving the entire contents of the web page, and we are scraping only the values that are links from the HTML. And then we're going to print out all the matches. So if we're calling find all here. And chat, what does the B do? We're calling find all against the contents of this web page. What does the B do, chat? Of course, Dan, it was great to have you here. Ghibli says, I remember the Inuyasha web rings when I was 11. Oh. The bee, it buzzes. Good answer, Ghibli. Cran says it turns it into bytes. Convert to bytes. So yes, technically in this case, what we're doing is we're writing out our regex in plain text, right? Because that's how we know how to write it. But what we're doing here is we're saying, all right, the data we're getting back from this web page is in byte format, right? And so if we want to match regex against something that's in byte format, we have to convert it into byte format. And so what this is going to allow us to do is say, all right, match bytes to bytes. And then when we print it, we can decode it. So it's going to print out as string, but we're actually doing the match against bytes to bytes, if that makes sense. So it's important to remember here that, yes, we write out our regex in strings, but that's not what we're getting back from this web page. We're getting back a series of bytes, and so we need to match bytes to bytes, and then when we print it, we'll decode it into strings. All right. Read returns HTML source code as bytes. Yep. And gives us a list of all the strings that match our regex by returning only the link text between the double quotes. And then we should get a list of links. So much biting in Python. Yeah, Pythons do bite. You're killing it with the puns today, Ghibli. So regex work very nicely when our HTML is well formatted and predictable, but since there are a lot of broken pages out there, a solution only using regular expressions might either miss some valid links or end up with bad data. This can be solved by using a robust HTML parsing library. Ooh, something like Beautiful Soup, perhaps? All right, but before we get to that, we're going to try this first, and then we're going to take a break, and then when we come back, we're going to get into the good stuff. We're going to get into our dear friend, Beautiful Soup. All right, let's do another file here. We'll call this URL regex. Hi. Save. Okay, we want to enter a web page here. Let's see, what do they want us to do? docs.python.org. Enter that. Say okay. There we go. It's going to give us all the links on this web page. Perfect. That is so cool. I know, right? It is really cool. Yeah. Sometimes it's fun to just appreciate the magic of what's happening, right? Cran says href and then gave some regex here. Regex would also work. Yeah, let's try it. I mean, hey, if we're not sure, let's give it a go. All right, so paste this in here. Let's see. Oh, I need to wrap it in quotes. Yeah. I think we're going to need to do like that. Let's try that. I'm not sure if that'll work, but okay. Nope. Okay. So that did not work. Actually, yeah. So let's try this instead. I don't want to open it. Just want to grab the text. Paste. Okay, so closer. It grabbed the first part. But it didn't grab the other parts. Almost good, right? So it's not capturing this bit here. Oh, and I wonder if that is because of, pull this back over here. I wonder if it's because of this href. Yeah, because I wonder if it's because of this href distinction here. Let's see. Well, feel free to try to, it's time for us to take a break, but feel free to try to work on that during the break. See if we can figure it out. I need to go get some hydration here because I'm out. But yeah, of course, feel free to tinker with it. But we're going to take a 5-minute break. And then when we come back, we're going to get into the good stuff. How do we use Beautiful Soup to do better HTML parsing? So this is, again, what Python is basically built for, this type of large-scale data processing, working with huge chunks of data using built-in packages such as Beautiful Soup. So really excited to get into this. I will see you all in 5 minutes. And yeah, let's get to grinding up some data, shall we? Alrighty. See you back here shortly. Alrighty, folks, we got about a minute left in the break, so come on back if you're coming back. As always, make sure that you are stretching, make sure that you are staying hydrated, and as always, please pet your dogs, pet your cats, pet your significant other with their permission, of course, and then come on back. Alrighty, welcome back, everybody. Hope you had a good break. Good troubleshooting there on the regex crayon. What they discovered is that I accidentally chopped off part of the regex there. So let's put the proper one in there. Get that. Yeah, so essentially here, what it's actually, oh, and you can't see that. Hang on. As they say, this regex actually looks for anything that essentially is in a link tag. So an href in a link tag, href equals, and then the only part that gets returned is what's in the parentheses here. And so we're specifying, hey, we want this part of this string to be returned, not caring about the href tag, not caring about the quotes around it, but we want to check for this entire string. So we want to check for this entire block of regex, but we only want to return what's in the parentheses here. Yeah. So that's what was missing. And then just doing the encode after it there. Yep. Good catch. Okay. So let's look at Beautiful Soup. Love the name, by the way. So what is Beautiful Soup? Well, HTML does look like XML. I'm sure you've seen both before, and they do look very similar. Some pages are constructed to be XML, but most HTML is generally broken in ways that cause an XML parser to reject the entire page of HTML as improperly formed. That does not surprise me. There are a number of Python libraries that can help you parse HTML and extract data. Each of these libraries has its strengths and weaknesses, and you can pick one based on your needs. So we're going to simply parse some HTML and extract links using the Beautiful Soup library. Ghibli says, Ember, my cat, says, thanks for the break. She appreciated the extra pets. Hey, that's why I say it, you know. Got to pet your dogs and cats and kids and significant others with their permission. Show them you love them. All right, so Beautiful Soup tolerates highly flawed HTML. Oh, good. That's the only type of HTML I'm capable of creating, and still lets you easily extract the data you need. You can download and install Beautiful Soup from there, and then information on installing Beautiful Soup with the Python package index tool, or pip, is available here. All right, so we'll do that in a second. Absolutely, you know, hey, if you're gonna pet a human, you know, you should ask them for their permission first to make sure that that's something they're going to appreciate and enjoy. Everything's better when you ask for consent. Okay, so we're going to install those in just a minute, but let's kind of finish looking at what's going to happen here. We use the URL lib to read the page and Beautiful Soup to extract the href attributes from the anchor tags. Okay, so we can download the zip, unzip it in the same directory as the file. I'm probably going to install it with pip, just because I know I'm going to be using Beautiful Soup a lot. So I'm probably just going to straight up install it rather than using just like a local version here. But we're going to import all the usual stuff. We're going to also import Beautiful Soup, and then we're going to import SSL as well, ignoring certificate errors. We enter a URL, and then we read the contents, and then we run it through Beautiful Soup as HTML. So here we're saying, all right, call Beautiful Soup, specifying that we're passing in HTML, or passing in this HTML, and then we're going to call the HTML parser on it. we're going to retrieve all the anchor tags, and then we're going to print what we find. Oh, okay, cool. We're going to print anything with an href. That's neat. Yeah, we're going to print out the href attribute from each anchor tag. Oh, that's super cool. That's slick. So essentially, we're capturing the anchor tag data, anything that's in an anchor tag, and then specifically within those anchor tags, we only want to retrieve the href attribute, because technically, I mean, there could be other attributes in those anchor tags, but we just simply want to retrieve only things that are an href attribute, which are going to be links. Neat. Cran says, with the type of HTML I write, I'm not even sure if Beautiful Soup could make heads or tails of it. Yeah, I mean, if somebody's deliberately using the wrong tags, sometimes HTML will still render correctly, but it's going to be a lot harder to parse. Yeah, so there's no accounting for tag types. KP says, are you writing the codes in VS Code? Yes, I'm using VS Code for all this stuff. Dooku says, maybe you have it, try to import it. Yeah, I will try it before I try to install anything. I don't know if I have it or not. But yeah, we'll try that in a second. Reads the new. Okay, so when the program runs, it produces the following output. Neato. So yeah, it's essentially just grabbing. Yeah, it's grabbing not only valid links, but also anything that you could potentially link to. So things like, yeah, relative paths, in-page references. So referencing maybe to a specific header on a page, right? That could be an href. You can, in fact, you often use local hrefs to specific points on a page, right? In a menu. And so in that case, we can, use a regular expression to simplify it down to just, hey, I want external web links. I don't want internal references. So to kind of narrow it down further, we can use Beautiful Soup to pull out various parts of each tag. And I promise we're going to do these in a minute. I'm just getting through kind of what's happening here. So it's kind of all the same down to here. We're pulling out the anchor tags, and then we're looping through each tag to say, all right, print the tag, print the URL portion, print the contents, and print the attributes. So what do we get out of that then? So here's the full tag, fully formatted as an anchor tag. And then, what is it referencing to? So here's the link. Here's what the text that appears in the anchor tag. Here's the actual URL from the tag. Here's the content. So the interior text, which is essentially this. And then what are the attributes of the tag? So neat. So we can essentially take all elements inside that tag and process them separately. Very cool. Yeah. All right. So let's pause here for a second. Let's try this. Let's see if we can get it working. I'm going to go back up here. And let's just see. I'm just curious if I have Beautiful Soup already. I don't know. So if I do, I could probably just do import Beautiful Soup, like so. Oh, sorry. Hang on. I'm going to open. There we go. Import Beautiful Soup. Okay, so it looks like I don't have it unless there's another way to get it. So I'm going to have to install it. So let's go ahead and do that. From BS4 import? Okay, we'll try that. From BS4, oops, import. Gotta watch my spelling here. From BS4, import Beautiful Soup. Yeah. No, I don't have it. I didn't think I did, but it's worth a try. Yeah. No, because what they're doing here is they're having you download a zip file called BS4 first, and so that's what this import is doing. Is it's just pulling it locally from this zip file, but I want to actually install it globally so I can use it anytime, no matter what project I'm working in. So let's do this. So let's head here first. We're going to head over to Beautiful Soup here. That's really small. All right, and we'll install it with we'll just install it with pip. See if we can do that. Oh, I probably need to be out of the interpreter, right? Okay. Watch me stumble through this, folks. Yep, I know it's being installed globally. I'm fine with that. Okay. It says there's a new version of pip available. We'll try that. Oh, actually, no. I'm not gonna upgrade pip right now. I don't care. I just want Beautiful Soup. I don't care about pip. That's a problem for future me. All right. So theoretically, pip may be installed. And let's see if we can use it. So all I did there was I just copied, what it said to do. Just ran that command, and let's see if it worked. So now let's see if I can import it. So we'll go back to the interpreter here, and we'll just say import. Okay, module not found. No module named Beautiful Soup. All right, we'll try this full string. I don't know if that's going to do it, but that. Ooh, maybe. Okay. So yeah, from BS4 import Beautiful Soup. All right, now we're going to, so I just tried the import just so I could see whether or not it installed. So now we're going to try the full script. So I'm going to grab this whole thing. And we're going to try to run the whole script. Okay. We'll call this BS test 1. Paste that in. So all I did was just paste in the full script here. We're importing all these things. We'll save it. And we'll say pi bs test 1.py. Okay, it's working. All right, now we're going to enter, what do we enter? Docs.python.org. Hey, check it out. It works. We did it, chat. We're Python geniuses. Not really. The bare minimum. First try. All right, so yeah, we're seeing that we get kind of a mixed bag here, where we're getting a mixture of genuine external links, and then also just some things, interior references to pages. Here's a blank header, files, pages, all sorts of things. We're getting just random references to all those. So yes, and so we could reuse the regex we already have, right? That we used before to just retrieve the plain links. We absolutely could. Or we could go into the tags like we're seeing here. So we can use some of the power of Beautiful Soup to look for a specific tag and then look for the contents of the tag and print those out. So let's go ahead and do that. So, just like with many things, there's a variety of different ways we could approach this, right? We could come at it from a raw regex perspective, or we could use some of the built-in Beautiful Soup methods to actually look at the tags themselves and determine what attributes and contents we want from those tags. Yeah, and I would agree. I think instead of having to try to write the perfect regex for every possibility, instead we can use Beautiful Soup to say, hey, look, I know that if an anchor tag has an href, that's going to be an external link. And so no matter how that link is formatted, I just want to grab what's in that href attribute in that anchor tag. So that, yeah, rather than having to write perfect regex every time, we can just use Beautiful Soup to handle it. So let's do that. And in some cases, you're going to want to use one way. In some cases, you're going to want to use the other. Okay. I'm going to grab docs.python.org. Oop. Okay. Print contents, tag context, list index out of range. Okay. What's the problem here? What do we get? Okay, so we still got some results, right? We still got some content. So maybe something is formatted badly or something like that, but we did still get at least a partial result. We're getting the href, we're getting the class, we're getting the full tag, and then, you know, what's the URL, what's the contents, what's the attribute, etc. So yeah, pretty much working as intended. My guess is that there's just something here. There's just something here in one of the tags that, yeah, like this URL here. Maybe it's missing. Actually, yeah, that's probably it. In this case, it broke. See, because this URL is essentially empty. There's no URL at all. And so it's looking for, so in this case, it's not quite robust enough. Yeah, it's an empty href. And so it's looking for saying, all right, what's the first item in the contents? There is nothing. This tag is empty. So it can't print it, and it craps out. So that'd be easy enough to correct for, right? To say just, hey, if it's empty, just skip it, print an empty string, and go on to the next one. So just maybe it needs a little more error handling there. But yeah, overall, it's working as intended. So we're pulling out the various parts of each tag. And there's a bonus section if you are a Unix or a Linux user as well. And of course, you know, as we're kind of seeing here, there's a bunch of different things we could do. I think in my case, generally, I'm going to be most concerned about looking for specific tags. In the data I'm going to be parsing, I think I'm going to be looking for, let's say, mostly like names in a header tag, right? I know that in the format of the page, names are going to be in H3 tags. So I can loop through and I can pull out every H3 tag. But from there, I might find that there are additional H3 tags on the page that I don't want. Things that aren't names, things that are just, you know, formatting for other parts of the page, etc. So I can say, all right, I want only H3 tags with the with like the ID, or with like the value of name, right? First, you know, I can see how they're formatted for CSS, right? And so I can say, okay, or with the class of name. So I can pull out that specific attribute and say, hey, only give me the contents of H3 tags that have a class of name. I'm just throwing that out as an example. We'll look at the web page after we're done with this course. But yeah, so only get me H3 tags with this specific attribute and print the contents. And that should give me, you know, a list of just nothing but names, or something that's close enough that I can filter out any garbage data from there. And then, you know, if I want to say, okay, cool, that gives me the names, and then I can look at the format of the other data and say, all right, now give me, you know, what's in these other tags and their attributes. So I think Beautiful Soup is going to be exactly what I'm looking for in terms of scraping this data and giving it to me in a format that's going to work for me. And I'm probably even going to have it take the data, format it in a specific way, and save it in a text file or an Excel file. I think actually I'll want us to save it in a CSV, so that way I can quickly import it into a database. Hey, Brave Traveler, good to see you. And sorry, I think I just missed a follow. My feed isn't working because I had to restart my stream earlier. So let me just see who followed me. Oh, Pac-Man Jr., thank you so much for the follow. Good to have you here. Sorry. Sorry, I had to flip over to my bot there to see who followed me because I can't see it in Streamlabs. Oh, everything's broken. Okay, that's fine. But yeah, this is going to be extremely useful. Maiva says, can we only scrape data by looking at the tags? Nope. So like we saw earlier, we can use regex to just look at any part of the page that we want. So we can use regex to just look at any part of the HTML regardless of tags. So if we wanted to only, if we only wanted to find how many times the word John appears on the page, we could use regex to look at the HTML raw independently of anything else and just return all, the count of instances of the word John, regardless of what tag it is, what tag it's in, or if there's if it's actually a name or anything. We could just search for a specific string and return any instances of that string. So yeah, with the combination of regex and Beautiful Soup, we have a variety of different ways that we can look at this HTML data. And I think that's really cool. Good to see you, Brave Traveler. Okay. So yeah, I think we are as of today, we are finally armed with the basic resources to embark on a major data project, and the whole reason why I started taking this course in the first place. So that's pretty cool. Oh, I need to go back to the right page. Hang on. Okay. All right, there is a bonus section down here for Unix or Linux users. So if you're on Arch BTW, then your ears might perk up here. We can use curl to retrieve both plain text and binary files using HTTP. So yeah, if you've used curl before, we can use that as well to retrieve binary files with URL lib. Let's see. Yeah, so we can use curl or wget to retrieve the data at these locations as well. I have used curl once or twice for work. I don't remember the exact purpose, but yeah, it was to do something like retrieving, I was retrieving some text files or something like that and just ran curl to retrieve that data. So yeah, you can use curl or wget. All right, so now let's go ahead and go on to the auto grader exercises. We're doing pretty well on time, so we're going to move on to the exercises. So now that we've practiced this a few times and we've read through the data, that doesn't mean we understand anything at all, right? We know that. How many times in college did you try to study for a test just by reading the information and then hoping it was somehow in your brain, and then you go to the test and you try to actually apply that information, you're like, wait, I don't understand anything. That happened to me a lot. It was very frustrating and I didn't understand why, but it turns out it was because I was just reading the information without retaining it or processing it at all. And so the best thing we can do for ourselves is to read the information and then immediately turn around and see if we can apply it to an actual scenario and test whether or not our brains have actually processed what we've read. Because repetition is, or mimicry is easy, application is hard. All right, so let's try it. So we'll go back to the menu here. Oops. And we'll go back to lessons. And we're going to test our knowledge of the request response cycle. And then we're going to try scraping some HTML data. And then we're going to try some following links. We'll see if we can get all three of these done. Yeah, exactly, Dave. Active recall and spaced repetition, indeed. Another way that we practice spaced repetition is by starting off each stream with a quiz on the previous topic that we did a week before, right? So application and repetition are the two most important components to learning, in my opinion. Alrighty, so exploring the hypertext transfer protocol. We are to retrieve the following document using HTTP in a way that you can examine the HTTP response headers. All right, so with that in mind, we're probably not going to use the the URL lib package. We're going to just probably do a raw GET request against this this target here. So we're going to want to retrieve the URL and print out the headers and data. And then we're going to open the URL in a web browser with Developer Console and manually examine the headers that are returned. All right, so and then they want us to enter specific header values in the fields below. I like this. This is fun. Imagine if you'd have to write a program to scrape the quiz from the site. Hey, I don't put it past Dr. Chuck. Okay, so we do have a template for this, right? A way to modify the header, or a way to take a look at the headers. So let's see if I still have it here. This is why we do all the examples in the text, because they come back around in the exercises, and it's helpful if we have them. So, I wish I would have labeled them better. Let's try it. Okay, so simple HTTP. Yeah, there we go. So this should hopefully be what we're looking for here. All this is doing is it's saying, all right, connect to the socket, get whatever's at this location, and essentially just retrieve the headers. Let's see, I don't remember if this is retrieving the, well, let's see what we get. We're going to try it against this particular location. And let's see what we get back, because I don't remember exactly what this is going to do. Okay. Oh, that's right, because I deleted the oh, this is just going to get the contents, and that's okay. We'll just do that first, and then we'll get the headers instead. Yeah. So what this does is, well, it's going to retrieve both, so that's fine. Okay. So we're getting both the headers and the contents, but we really only care about the headers here, right? So it's saying, all right, what is last modified? Saturday, May 13th, blah, blah, blah. We have the E tag. All right, so let's try putting each of these in. I'm not sure if this is exactly what it's looking for, but let's try putting each of these values in. E tag. I hope it's okay if I don't put the quotes in. Content length, 467. Cache control is that. Content type is plain text. Okay. Okay, so content, oh, wait, 460, I just didn't copy the whole thing. So this should work. Hooray, we did it, chat. How nifty indeed. I know, isn't that neat? Yay, correct answer. The first time I just missed it because I accidentally didn't copy the 7 in the full length. So I had the right answer in spirit. Yeah. So I did that kind of quickly, but essentially what we did was, all we did was, instead of using the that sort of URL lib package, we just did a raw connection to the socket and a raw GET request, and just looked at the full contents of that response. So, you know, normally the URL lib is going to just kind of help us do away with some of that extra stuff that we don't normally care about and just show us the content. But in this case, we wanted to see the headers. So we just did a raw request and just looked at the entire contents and examined the headers for the information. Okay, hooray. So we'll say done. We'll do the next one. Now we get to use Beautiful Soup. So we're going to scrape some numbers using Beautiful Soup. Write a Python program, use URL lib to read the HTML, parse the data, extract the numbers, and compute the sum. Okay, so we can look at a couple different files here. We're reading data directly from the URL. I like this. Each student will have a distinct data URL for the assignment, so only use your own data URL. We're all going to share this one, unless you all are doing it at home for your own, you know, edification. Edumacation, whatever. The data format is going to look like this. So we're going to have kind of a standard, kind of tag format, it looks like. We're going to find all the span tags in the file so we can see that the numbers we're looking for are in span tags, and pull out the numbers from the tag to sum the numbers. So we can look at this sample code to show how to find a certain kind of tag, loop through the tag, and extract the various aspects. Yeah, so this is kind of what we did before, right? We looked at the various aspects. Instead of printing each aspect, though, we're going to want to just get the contents and sum those. Yeah. Alrighty, chat, let's do it. Okay, so we can kind of build off of the last exercise we did, which was this, right? We still have this. So I think we can use this as our base. We've got beautiful soup. We're ignoring SSL errors. We can have it input a URL. We're going to read the contents. And we're going to look for, instead of an anchor tag, we're going to look for a span tag. So I'm going to start off just by printing the contents to make sure we're getting the right information. So we're just going to say, all right, look for span tags and just print the contents. I don't care about any of this other stuff. Just print the contents of the tag for every tag that it can find on the page. So let's try this. So we'll say pi.ps test. I should come up with a better name for this file. .py. Oh, oh, yeah, I did that wrong. Test1.py. Okay, so now let's feed it this first sort of control file. Enter the URL. Okay, hey, check it. We get all the numbers. Great. That's awesome. Yeah. Okay, so that's what we're looking for. That's at least that's the content that we're looking for, right? So now we're going to need to take each of these and we can add it to a count, right? Or we can add it to a sum, sorry. Let's do running total equals 0. So we'll set up our running total, and then we're going to extract, instead of printing it, we're going to extract the contents, and we're going to say running total equals running total plus that. And then at the end, we're going to print out our running total. Print running total. Let's try that. Okay, let's see if that works. Oops. Enter page. Space after that. Oh, okay. Oh, yeah, that's right. What am I missing here, chat? Why did I get that error? So I got an error, and it says unsupported operand types for int and navigable string. Why did I get that error? What was the problem? Exactly. Yeah. By default, this information is being returned to us as a string, right? Yeah. So what we need to do to fix it is convert it to an int. Even though it looks like a number, it's not being read as such. So we need to, yeah, data type is different. Exactly. Yep. So we just need to do this. And we need to convert it to a string. Yeah. And so with that, we now get a sum of 2553. So that matches what we see here. Yep, that matches what we see here. And so now let's try it against the real deal. We should have our sum ending in 71. So we'll run it again. And there. Yay, we get 2771. Let's see if that's right. 2771. Oh, and I guess we got to put in our Python code too. Okay. So I need to clean this up a little bit now. Okay, retrieve all the span tags. Look at the, I didn't know I was gonna have to turn this in. Content of the tag and add it to the running total. Didn't know there was gonna be an actual assignment to turn in. Save that. Okay. Copy this whole thing. Maiva says, I wonder if you can use the sum function of doing sum int tag contents 0 instead of keeping running total. So I think we need to keep in mind there that each time we're looping through, it's retrieving each tag individually and putting its contents into like a new list. Yeah. So each loop is only going to have one number. So we can't just do a straight sum inside the loop because then the sum would just be one number. Yeah. Right. Now, if we wanted to, we could, instead of doing the sum here, we could write each number to an ongoing list, right? We could do that. We could add each number to the end of that list. And then in the end, we could call the sum function and just sum the entire list. But either way, I mean, it's kind of 6 of one, half dozen the other, right? Whether you add them all to a list first and then sum after, or sort of just keep a running total as an integer as you're going. Yeah, in this case, not a huge difference either way, I don't think. But yeah, it could be, you could do it that way, certainly, as long as you just do it in the right place. Yeah. All right, so I'll drop my code in here. Do. Okay, we'll submit. Hooray, correct answer. First try. Yeah, no worries, Mavi. Everybody thinks a different way, right? So, you know, the approach that's the most logical to me might not be the approach that's the most logical to you. And so you might choose to do it the other way, and that's fine too. Okay, so we did this, and then let's do following links. That's the last auto grader. Grouping is weird. Yeah, grouping is weird. So we're going to use URL lib just like we did before. We're going to extract the href values from the anchor tags and scan for a tag that's in a particular position relative to the first name in the list. Okay. Follow the link and repeat the process a number of times. Report the last name you find. Okay, so it's kind of like doing a web crawl, right? We're clicking through links until we get to the last name we find. One is a sample file. Okay. So let's just take a look at what's in this file because I'm not sure I fully understand yet what this is wanting us to do. Okay, so what do we have here? Oh. Ah, hey, I was trying to look at the thing. Okay, hang on. So it's just a series. I'm just clicking reload so it stops going away. So it's essentially just it's just a list of names that link to each other. And it's trying to be anti-cheat to say, hey, make sure that you retrieve and process the data in a Python program rather than simply counting down, pressing links, and doing the assignment without writing a Python program. Not that I was going to do that. I just wanted to look at the underlying data to try to understand what it was asking for. Your Python program can look at the page as long as it likes. Okay. I didn't do anything here. The page just did that automatically. Thanks, Dr. Chuck. All right. So we want to find the link at position 3. The first name is 1. Follow that link. Repeat the process 4 times. The answer is the last name that you retrieve. Okay. Da, da, da. So it's essentially saying don't cheat, write it in Python. That's what I was planning to do anyway. All right, here's a sample execution. So we enter a URL, we enter a count, we enter a position. And it's going to retrieve each link. Okay. I'm going to have to tinker with this a little bit. I'm not 100% sure what it's wanting to do, but we'll get there. Okay. So we have kind of a skeleton for this, right? We've done this before. So I'm going to create a new file for this one because it's a bit more involved. So we'll do, let me call this link follow by. Okay. And this should be our starter code here. Grab all this. Oops. All right, so what do we have for our starter code? Enter a URL and retrieve. Okay, so it's essentially just what we already did, right? Look at an anchor tag and get what's in the href. And this is printing it. However, I think what we're going to want to do is essentially go to that link and then repeat the program, right? So we're kind of doing some recursion here, right? I think instead of we have a starter URL that we enter, but instead of that, we're going to want to go to that first link, retrieve the href value, and then go to the next link for X number of times. So at minimum, we're going to need a count and we're going to need a position. So what does position mean here in this context? Find the link at position 3. What does position mean? Scan for a tag that is in a particular position relative to the first name on the list. First name is 1. Okay. Repeat the process 4 times. So essentially, go to the link at position 3, and then from that, then go down 3 again, 3 again, 3 again. Okay. I'm going to look at this again. So I'm just hitting reload over and over again. So, all right. Start with Montgomery, go to that link. 1, 2, 3. That's Mahairaid. 1, 2, 3. That's Butchie. Yeah, okay, there we go. And then 1, 2, 3. That's Anaya. So that's the last link there. Okay, I get it better now. I needed the visual. Yes, position 3 is going to be index 2. So what we're gonna, I think the way to approach this is I want to start out by just going to the starter link and retrieving only a list of names. I just want a list of names. So I want to get, let's see. So in this one, in the exercise we did previously, we're looking for span tags. Now we're looking for anchor tags. And I want to get essentially I want to get the contents and I want to get the link. So I want to get I want to get the tag, contents, and I want to get the href. We're just going to start with that. And tag dot contents. Let's just try this. All right. And then after that, what we're going to do is we're going to take, assuming we can get the contents we are expecting, or the information we're expecting, I want to put all the links into a list, and then I'm going to print that list, and then we want to just go to the link at position 3 or index 2, as Crayon mentioned. We're going to go to the link at index 2 and repeat the process. So we're going to kind of whittle this down over time. All right, print tag. Okay, save that, and then pi link follow dot pi. Okay, we're going to enter the URL. Okay, great. Yes. So this is giving us a link, a list of all the names and their links. So here we have the actual link, and then below that we have the name. So that's working as expected. Great. Now let's only print the information for the link and the name that's at position 3 or index 2, however you want to say it. So we're going to hard code this for the first time, and then we're going to make it into a user entered variable. Let's see, how do I want to do this? We could do for tag and tags. We could have a count variable keeping track. So we could say so we start at index 0 and loop through each one. And so we'll say if count equals 2 for index 2, then print this information. Otherwise, don't. Let's see, why doesn't it like that? Oh, equals, yeah, sorry. If count equals 2, then print this information. Otherwise, don't. And at the end of it, we increment count by 1. Plus equals 1. All right, let's try that. I'm happy to know I'm not the only one apologizing to my IDE. Oh yeah, I do that all the time. I'm always apologizing to inanimate objects. Okay, so now what I'm hoping here is that we should only get one print, and it's going to be, what is it going to be? It's going to be, I'm hoping we only get 1, 2, 3. I'm hoping we only get Montgomery here. Let's see. Enter the information. Yeah, awesome. We did it, chat. So we printed out the value at position 3, then both the link and the name. Woo! Yeah. Okay, we are step 1. That was step 1. So we have the information at position 3. So now, well, I think I'm still going to keep printing it just so we have it. But what we're also going to want to do is essentially then go to that link. Maiva says, I love how you broke it down into smaller pieces. Hey, that's really the only kind of way, that's really the only way to approach these types of problems, as you have to break it down. And that's another mistake a lot of newer developers make, is that you say, oh, I want to build a full stack app, and then they try to do the whole thing in one bite. If you can make a minimum viable product first to approach it in smaller steps, then you're going to have a much better time. Yeah, we eat the elephant or the whale one bite at a time. Exactly. Crayon says, I think you could also use tags too. Yes. Yeah. Let's do, because yeah, we are already putting this into, yeah, that's right. So let's do print, instead of doing the manual increment, let's do this, and we'll try that as well. That'll make it smoother. So we'll print tags 2. because yeah, you're right. It's already auto grouping this into a list for us. We don't have to do that. So do this. And we should hopefully get the same result. Yeah, so we did. Perfect. Great. Awesome. Okay, so now another thing we're going to do is we're going to make it so that, well, let's see. We're not going to do that yet. We are going to have to make it so that the user enters the position and the number of repetitions, but we'll hard code it for now. Okay, so we're printing those, and then what we want to do in addition to printing them is then also go to this link. So we are going to need a loop to say how many links we should go to. Oh yeah, I could also hit the up arrow. Yeah, I've been doing that for a lot of other things. I don't know why I didn't do it for the URL. Who knows? Why do our brains work the way they do, right? Okay. So I don't need this anymore either. Great. Okay, now I am going to want to put these back into a loop though, because I need to tell it how many times we want to go to the next link. Cellophane says, are you grabbing the A tags in HTML? Then it makes a list with those things inside the brackets? Yes. So we're using Beautiful Soup here, which is just a Python package where it can identify specific tags. So that's why, I'm calling, that's why the function I'm calling is soup. Because what it actually is an HTML. Of course, no worries, Cellophane. What this actually is an HTML parser powered by Beautiful Soup. So it already knows what these tags are. And so we just call soup on the anchor tags. And from there, it's going to put all the information in those anchor tags into a list called tags. And then from there, we can pull out specific tags that we want, such as what is the third tag? And then what is the contents of that tag? It is beautiful, I know, right? Grant says soup, a tasty too. Yeah. Yeah, I could hard code it. I'm not going to bother with that, at least at this point. Icefire says, do the URL, HTML, and soup lines. Sorry, do the URL, HTML, and soup lines need to be a part of the loop? Yeah, so that's the next thing to think about is what should the loop be? I think in this case, the first where we do this manual entry, that needs to be outside of the loop because only the first URL is human entered, right? So this is only needed once. We don't need this more than once. After that, we want to simply reassign the value of URL, visit it, and get the contents. So yeah, I think what we're going to do here is everything but this. So everything but the first entry is going to be part of the loop. So we're going to want to say, so we want to control the number of repetitions. So essentially we're going to go through this whole thing and then we're going to reassign URL now equals, instead of printing this, we're going to say link. We're going to set the value of URL equal to the current link. And I know I could just set it directly equal to this, but I'm just kind of working through the thought process for a moment here. All right, so we define the value of URL first by whatever the user enters. We're going to start a loop here. Loop start. And then loop through. At the end of the loop, we're going to reassign the URL to whatever the link is that we clicked on, or the link that we found. And then we're going to, loop starts up again. We visit that URL. We do the same thing. But we want it to stop after X number of repetitions. Yeah? Okay, sounds good. All right, so now I need to remember how to write a loop that runs X number of times. Okay, so essentially I could do it as a while loop and increment like a counter for each loop. I know how to do this in JavaScript, but I'm spacing on how to do it in Python. But a for yes, but so I can do it as a while loop, but a for loop is probably safer. Yes. Um, so I think I have an example here. That's why we keep all these, right? Let's see. I think a lot of the times we've been doing it for like a arbitrary number, not a hard code. For I in range. Okay, yeah, we can do that. So for I in. So we'll hard code it for now. We'll hard code it to 4, and then we're going to make it into a variable. So then we got to indent these because we want this whole thing to be a part of it. Get rid of this comment for now. Whoops. Oh. Reassign it. Crayon says, I was always taught to use underscore if we're not actually using the index in the loop. Yeah, and we could declare this as, for X or something like that. And then, oh, it should be for, okay, I want to use whatever is the proper, thing. Okay. And so then, yeah, not using the I. Yeah, that seems appropriate. We're not actually using an index here. We're using an arbitrary number. Okay. And so then how do I do the increment then? So is it going to be, do I need to do like plus plus or whatever? Yeah. I like it. Yeah, it's one dash says, how are you liking Python so far? I like it a lot. Yeah, it's great. Oh, it auto increments. That's rad. Okay, coolio. That's dope. I dig it. It makes me like Python even better now. Yeah, no, this Python has been really great so far. I'm actually a data engineer. Like that's my day job is I'm a data engineer. And I actually haven't known Python so far, but I wanted to learn it because it'll make me better at my job and it'll help me with some personal projects. And so far it's been a blast because all this stuff is right up my alley with the type of stuff I do at work. So, and the course itself is nice and challenging. It's not easy by any means, but it's also not too hard, which is nice. Okay, so does this look okay, chat? Anything I'm missing here? I'm printing each one. Oh, and I also still do want to print the link too, actually. Hang on. Just so we have it. Print that. Save. Reassign. Go back to the link. Do. Okay. Yeah. I know I could use the up arrow. I'm just got it in my, my brain now to do it the other way. Okay. Hey, check it, chat. We got Montgomery. We got Mahiraid. We got Butchie. We got Anaya. Last name in the sequence is Anaya. All right. We did it. Thanks, chat. No, and I really appreciate you all sharing this little shorthand for looping through a static range, because that's not something I think we've really done in this course. It's just doing a static, like we've done a lot of, looping through an arbitrary range, like however many items there are in a list, right? Or however many items there are in a dictionary, loop through that. But what we haven't really done is just, here is a static number, loop through that. So it's good to know. Yeah, and it's a range object. Yep. It's just an iterator. Yeah, and yeah, that's what I figured. It's just kind of like it's just a thing. It's a self-defined thing that we can just iterate through. It's the integers from it's the integers from 0 to 3. Yeah. That we can loop through. But yeah, we are going to, so now the next thing we need to do is, if we try to run this against the actual data, it wouldn't work because we hard coded the values of the position and we hard-coded the value of the number of iterations, right? So we need to turn these into user-entered variables. So we can modify this slightly to say, all right, URL input enter, and then let's see, how did they have it formatted here? Okay, so we want to say like enter count. So we're going to say count. We'll just kind of match this formatting here. URL. So we define these variables. And then position. Oops. Position. Okay, so enter position. URL count and position. And then we want to set essentially, want to loop up to this count and return the value at this position. So we'll take this, cast it as an integer, and do that one. And then so for that in range count, so we'll say int, cast this one as an integer as well. And then, yeah, let's just see if that works. And yeah, I'm thinking we may need to turn this back to I because this is now like a legit thing, but I'm not sure. You guys tell me what the convention would be. If we're dealing with actual user input for this range, is it still that as far as best practice? Okay. Somebody asked the question, so I just wanted to see what is the right practice here. We still want to, and we still want this to auto increment, and yeah. Okay, let's try it. And yeah, there's nothing in the, that's correct. There's nothing in the loop itself that needs the index. We are just using this as a iterator. We're not using the index in any capacity here. We're just iterating through X number of times. Okay, so I'll take that as, we can leave it as is. We'll do this. So our URL open, I should have formatted that better, but that's okay. Okay. We don't need to do position -1. They want us to use the value at position 3 for each link. So we don't need to change that value, at least in my understanding of the problem. But we'll see if that's wrong or not. All right, count is going to be 4. Position is going to be 3. Okay, so not quite. Oh, I didn't copy the right, hang on. I didn't copy the right file. All right, one more time. All right, there. 4 and 3. Oh, maybe I did. Okay. So I got a different answer this time. Let's see what happened. So number of loops, that's correct. 1, 2, 3, 4. But the position is not. Oh. Oh, I see. Okay. Yeah. Yeah. I see what you mean, Umthim. You're exactly right. I thought you meant subtracting 1 on each iteration, so it was counting down to 0. Yeah. Okay. So it's going to need minus. It is going. You're right, Umthim. It is going to be -1 because we're doing, yeah. Yeah, position is going to be 1 higher. Exactly. So we'll just do that. That's fine. Oh, wait. Nope. I did that wrong. I need to do -1 down here. Yeah. Because index versus, yep. Actually, wait. I'm not going to do it like that. That's stupid. Hang on. There. Okay. So So I went kind of fast there. All I did was I just said, okay, hey, they're giving us the raw position. Like if I say it's going to be in position 3, but if I want to look for that in a list, I need to look at indexes. And so 0 indexes are going to be how we figure out what position something is in. So, the item in position 1 is going to be at index 0. Item at position 2 is going to be an index 1, et cetera, et cetera. So if I want the thing at position 3, I'm going to look at index 2. So that's why I'm doing a -1 here to actually give the correct position. Okay. So again, count is 4. That's how many loops we want. Position is 3. Hey, check it. That gives us the name that we are looking for. We got it, chat. Now the last thing I want to do is just format this a little better. Woot woot. Yeah. Good job, chat. All right, now let's do the actual problem. The first character of the name on the last page we want to load is F. We did it, boys. Yeah. Okay, so let's see if we get that. We're going to grab this URL. Enter the URL. Our count is going to be 7. Our position is going to be 18. All right, what do we get? Our final name is Freya. And they said the first character of the name on the last page you will load is F. I think we did it, chat. Let's see if we get it first try. Oh boy. I love this. This is so much fun. I don't know. I hope you guys are having fun. I'm having fun. Okay, and I'll grab my Python code here. I'm going to kind of clean this up a little bit just before I turn it in. I'm self-conscious. All right, import. Enter URL, position, and count for the first iteration. Start at user entered URL and use position and count variables. Okay. Find the anchor tags. And then I could also then simplify this a little bit more to just grab the value of URL and set it directly instead of, so I'm setting this intermediate variable here of link, but I don't really need it. So I can just do this and set it directly like so. So just set the next URL directly to the next link essentially. Find the next link to click at the start of the next loop. Okay. Copy and paste that code in. There. All right, let's see if we got it. Name was Freya, right? Yep, Freya. Oh, we did it, chat. Yeah. Ice says, do we have to match their output exactly? No, not in this case. Some of the problems, they do make you match it exactly. In this case, the only thing the problem is actually asking for is just this name value here. Yeah. In this case, I think the only reason it's asking for our Python code is just to make sure that we did it, right? It's just to make sure that we didn't cheat and just like click through the links manually, you know, which would suck, right? I mean, why would you want to do that? But I'm sure some people would. I think an earlier version of me might have tried it just to try to get around actually learning something. Like a high school version of me would probably have tried to click through the links manually just for the challenge. But this version of me actually wants to learn stuff. So the only reason it's asking for the code was just to make sure we actually did the work. And I appreciate that. All right, we'll say we're done. Now, the last thing we want to look at is I just want to look at this ASCII coding and binary thing. Hey, Gilga, welcome. They say, it's so satisfying to see people making codes. Hugs from Brazil. Hello. Hugs from the United States. Good to see you. Yeah, coding is fun, isn't it? It's fun to learn how to code, and it's fun to apply what you're learning to actually make stuff, make cool stuff. And that's what this channel is about. It's about learning to code and teaching coding and making cool stuff. Thank you so much for the follow. Good to have you here. I did put the code in. Yes, it just clears the form after I entered it, so I got the grade. If you look here, we can see that I'll have a grade for that assignment. So see, we've got did it. So it captured it. Don't worry. Yeah, and we're not going to do the quiz yet. We will do the quiz, but not until next week. But what we're going to do now is go back here and take a look at ASCII coding and binary, as well as Unicode. Cran says there was an advent of code problem where a lot of people basically went through the output by hand to find the answer. Hey, sometimes if the problem's too hard, then yeah. And honestly, I mean, there was a time before I learned how to have fun learning stuff that, I mean, I would have done that too. I would have in this problem, and rather than actually learning the code to solve it, I would have clicked through 18 links just to try to get to the answer without actually doing the work. I would have done that, but that's not who I am today. So it's a good to find the joy in learning, and it took me a long time, but I'm glad I'm there now. All right, let's look at ASCII coding really quickly. Oh, gosh. Okay, I didn't know it was a YouTube video, so let's not. I don't want to do that. You can look at that. Let's see, what is this? Okay, here. So these are 2 YouTube videos that you can look at, but I don't want to mess with audio levels and stuff like that. So feel free to look at those on your own time. Maiva says, I can only imagine how intense that was. You mean the advent of code problem? Maiva says, that's so interesting. He included binary and ASCII coding in there. Yeah, well, I mean, I think that knowing the difference between like different text encoding types is important. So things like Unicode and versus ASCII, like, or Unicode UTF-8 versus Unicode UTF-16, those can make huge differences when you're trying to move data between different systems. So that's something that I have to deal with at work quite a bit, actually, is moving data between a source system with a specific code page and then a target system with a different code page. So for example, we oftentimes move data from a system that can handle like more complex emojis. So like with it's like a UTF-16 or code page or something like that. And we're moving this data to a UTF-8 system. So a system that only has a UTF-8 code page. When that happens, we often encounter complex characters that simply cannot be rendered in that UTF-8 system. And so we have to essentially do regex to convert those characters or to simply eliminate them. And so, yeah, knowing the difference between those different types of code pages and what they can and can't do and how to parse them, I think is a good skill to have. Oh, Cran says, the advent of code problem where everybody looked at the answer or figured out the answer through brute force was a grid problem where there were robots on a grid moving a certain amount in Y and X directions. The challenge was, after a certain amount of steps, the robots form a Christmas tree. What's the first cycle where they do that? Wow, that's a tough one. Yeah, gosh. I could see how you might just want to like draw that one out. Yeah. Okay, folks. Well, we're going to save the quiz until next week. So I do want to have some time here, like we always do at the end of my streams. I want to give you all some time to let's have a little free for all here. Let's ask some questions. Ask me questions. Let's just talk about whatever you want to talk about. After 7,584 steps, took a while to find it. I'll bet. Dang, if you had to do it by hand. Gosh, that's wild. Alrighty, what questions do y'all have? It could be questions about, working in tech or something off topic or whatever you like. Maiva says, how was your holidays? My holidays were great. Thank you. Yeah, I spent about a week with some family, which was great. Unfortunately, my sleeping situation was not great. For the first couple days, I slept on an air mattress, and then the air mattress got a hole in it, and so I woke up like halfway through the night on a half deflated air mattress, which I don't know if that's something any of you have ever experienced, but it's like being in the worst hammock ever. Um, because you're just like, you can't hardly get out of it. And so yeah, the air mattress sprung a leak, and so after that I essentially was sleeping on like a piece of memory foam on the floor for the last few days. And so yeah, my sleep was not great. So yes, it was wonderful to see family. It was also wonderful to come home and sleep in my actual bed. I very much appreciated that. Because yeah, broken air mattress, not great. Crayon says, I may have missed it, but is the SSL certificate bit of code explained? Yes. So essentially what this is doing, so we're importing SSL here so that we can work with HTTPS URLs, right? So we can work with secure URLs. But in this part here, if the site we're trying to contact has an invalid SSL certificate, then we can essentially skip that verification. So we're just saying, hey, just don't verify that. Maiva says that's never fun. I woke one time slanted from an air mattress. Was too tired to move. Ugh, yeah. That's what I did the first night that the air mattress had a leak. I just like filled it up again and just tried to get through the rest of the night. But after that, it wasn't gonna work. So yeah. Hey, no worries, Gilga. Great to have you here. Feel free to come back again. Ghibli says, "Rip your back." Yeah, honestly, yes. Actually, I have a bad shoulder, and yeah, that was not great for my shoulder. Umtham says, "Hey, I joined an hour late and didn't want to interrupt. Just wanted to say the other day I saw Dr. Chuck's stream and I got to talk to him a little. He said you inspired him to stream. Oh, that's so nice. Yeah, Dr. Chuck actually stopped in and subscribed to me earlier, which was very sweet of him. He seems like a really nice guy. Um, so yeah, please give him a sub. Let's see if I can still. I think it was Dr. Chuck 42. Let's see. Shout out Dr. Chuck 42. Let's see if that works. Yeah, I think that's them. Let's make sure before you all follow this random person. Hang on. Yep, that's him. So yeah, please do give Dr. Chuck a follow, um, especially if he's starting to stream, because he's the person that came up with this wonderful course and all this wonderful content. And so please do give him a follow, show him some love, um, and yeah, send some traffic his way. Maybe that'll encourage him to stream. All right, folks. Any other questions? What else do you want to know about me, or working in tech, or 100 devs, or questions about the work we did today, the problems we did, which were super fun, by the way. I love these exercises. I feel like I have what I need to start with this project that I'm working on now, which is awesome. Although there is more to learn. We're going to be covering, I think the next time we're going to be covering web services. So this is probably going to be like working with APIs and stuff like that, which should be interesting, coming at it from a sort of a JavaScript context, seeing how we could do it with Python as well. But yeah, what questions, or what do you want to talk about? I say we've got about 10-15 minutes. But yeah, this is the roadmap. We're on the home stretch, by the way. I think when we actually get to the databases section, we're going to be covering SQL, which is going to be fun for me personally. I should hopefully be able to ace this part. Oh, thank you, Maiva. They say, just curious, do you come to each session pre-planned? I love how informative and fun your sessions are. Well, thank you. That's very sweet. It depends on what I'm covering. So in my non-Python content, absolutely yes. I come pre-prepared for every session. If in any session where we are like building a project, so something like where we build a full stack app, I've already done it. I've already built it. I've already worked through the kinks. I've already solved any errors that might pop up. And I already have the project finished, and then I just rebuild it and teach it live on stream. For this Python content, I've been doing it a bit differently. I've actually been coming in blind. I think I looked at like the first couple lessons while I kind of got a feel for the course and how the content flows. But after I saw how good the course is and how well prepared it was, I've stopped looking at the content ahead of time at all. I don't even scan it. I'm just coming in and seeing it for the first time, the same as you all. And we go through it together. We do the exercises, we do the examples, and then the next lesson we start off with the quiz from the previous lesson. So yeah, I'm not doing any pre-prep with this Python course because it is so well done that I don't feel like I have to. Now, when we go back to like regularly scheduled, my content where I curate what we're learning, I will go back to that same routine where I usually the day before I'll spend a few hours just putting together what we're going to cover, and practicing the flow, working out any errors, getting my notes ready, and then we cover it again here live on stream. So that's my general sort of process. Maiva says, I could not tell. I thought you were a Python expert already. Nope, I'm learning it just at the same time you are. But the nice thing is that when I'm speaking, when I'm reading through the information and teaching it to you all, it really embeds it for me at the same time, because I have to make sure that I'm explaining it in a way that, in a way that makes sense, right? And in doing so, I have to first understand what I'm saying before I can simplify it and explain it again to you all. So for me, it's kind of a litmus test to say, hey, do you really understand what you've just read? Or are you just reading it and repeating it? So it's a really good kind of it's really good to teach and learn at the same time, because it really makes sure that you're internalizing the content that you're reading. Crayon says, working with APIs sounds interesting. I've been wanting to make my own Twitch bot for a while, but the off bit confuses me so much. Oh yeah, Crayon, there's a lot of really awesome people here in the software game dev category here on Twitch who are building Twitch bots live on stream. So I'm sure if you popped into their streams and, say, hey, how did you get started? Can I look at your GitHub? That kind of thing. I'm sure there's tons of folks here in this category who'd be happy to help you with that. We've rated several people who are building Twitch bots, really cool ones at that. There's that one where it was like a battle royale where everybody who was in chat could like have their own avatar and they could all fight each other. It was super fun. There was the one with the little animals. I mean, there's been so many cool ones. Cellophane says, how many list comprehensions can you nest inside other ones until you lose your train of thought? I don't know. Yeah, that's me probably fairly quickly. Yeah, I would probably lose my train of thought fairly quickly, which is another, reason to write clean code, right? Yeah, my ADHD brain can't keep track of too much nested information. Your personal best is 4. Way to go. Yeah, and Maiva, kind of circling back to what I was saying before about like prepping for streams and stuff like that. When I was first learning JavaScript, I was basically doing the same thing of, do a little prep beforehand, read the material, do the exercises, and then, and then come and teach it. And there were times when I would read through some content or read an exercise and I wouldn't understand it. Like I could apply it, but I didn't understand why it worked. And then I would be live on stream reteaching the material to you all in chat, and I would suddenly get it. And I would be literally like comprehending it while I was talking through it with you all. And that's, that's a way that folks can really get better at this material as you're learning a new concept. It's just try streaming. If you're comfortable with that, just like try streaming and talking through it. Even if you have like one person or two people in chat, like, or even if you're just talking to an empty room, nobody's in chat, that's fine. Just talk through it aloud. It's kind of that rubber ducking principle, right? Where you talk to a rubber duck on your desk and you explain the concept to it. And then suddenly you find yourself understanding what you're talking about. Or you tell it to your dog or your, girlfriend, boyfriend, significant other, whatever. Yeah. Yeah, exactly. Live streaming is just rubber ducking with people. That's exactly it. You all could be bots and like they would have the same effect, right? I'm not saying that you don't matter, but I'm saying that the principle is the same whether you're talking to a rubber duck or you're talking to actual people. The important part is that you are essentially internalizing that information rather than just letting your eyes glaze over it and never revisiting it. Grant says the rubber ducky is usually slightly less judgmental. Nah, you all don't judge me, and that's great. We're all just learning together, and we're all going to make silly mistakes sometimes, and that's okay. There's no such thing as a silly question. There's no such thing as a silly mistake. ChatGPT and GPT can be helpful too. Just note that it may sometimes try to mislead you. It's really better when you're working with ChatGPT. It's important that you're the one driving the conversation, not GPT. So you can use GPT as like a sounding board or helping you simplify topics, but just make sure that you're the one in the driver's seat, not GPT. That you're the one in control of the conversation. Because yes, GPT is extremely helpful. I use it all the time, but I use it as a helper, not a teacher. So just make sure you remain the top dog. The human is in control. Alrighty, folks. Any other questions? Any other topics we want to talk about? And there's no such thing as, remember, there's no such thing as a silly question either. So if you have a burning question, feel free to ask it. That's totally fine. I'm going to double check here really quickly and see if I missed any followers too, because like I say, my follower feed isn't working since I had to restart. Just making sure. Okay, I think I got everybody. Cool. Don't want to miss folks. Cellophane says, have you seen that language called Python to make Python statically typed? I have not. That's interesting though. Is it kind of like TypeScript is to JavaScript? Kind of like it's just like, Python wearing a funny hat? Gotcha. Okay. Yeah, I mean that makes sense. It's the same reason that TypeScript was created, right? To just give a little bit more type stability to a loosely typed language. Typethon. Yeah. Typethon. Yeah, exactly. No, but I can see the use case definitely. You got all these loosey goosey languages hanging out there, and sometimes you need a little bit more stability. You can make your own libraries with it. That's really cool. Yeah, that's neat. That's again, like I mentioned, kind of at the start of the stream, is that we're all of us were standing on the shoulders of giants, right? All of us were just iterating on things that people have done before, and that's fine. People get hung up on, oh, I got to create something brand new. I mean, heck, no matter what language you're using, you're not making anything new. Everybody's done everything already, and that's okay. You're just making what you need right now, and somebody else in the future is going to do the exact same thing, and that's fine. We're all using languages that other people have built for us, and so hey, it's all just we're just adding one more Jenga block to the tower. Grant says, I've been making more and more use of type hinting while writing Python code. It's not necessary, but it makes your IDE yell at you when you're passing a wrong type of argument or returning something wrong. Yeah, kind of similar to the way it does with TypeScript, is that if you give your IDE the idea of what type something should be, then it can keep an eye on you and make sure that you don't use the wrong type accidentally. Yeah, that's good. So, yeah, similar to what TypeScript does. Okay, folks, feel free to ask any additional questions or bring up any additional topics that you want. I'm going to be pulling up the raid screen here in the background. But that doesn't mean we have to end the conversation now. I'm just getting it ready so that we can spread some love to somebody else, as we always do at the end of these streams. Oh my goodness. Thank you so much for the follow. Aurelio Kessler. Good to have you here. Thank you. Oh, and a common question that I get is are these streams recorded? Answer is yes. Can I watch them on YouTube? Answer is also yes. I'm going to be moving. So I have the first 6 episodes of this Python series already on YouTube. Um, and I will be moving some more over soon. Um, Probably within the next week, I'll be moving episodes 7 through 12. So everything up to regex. I will move over to YouTube. And then I'll move the final 5 episodes over when we're done with the whole series. So yes, the whole thing will be on YouTube. Yes, the episodes will be in a playlist, so you can watch them from start to finish. And you'll be able to watch it ad free on my YouTube channel as well. So I don't monetize my YouTube channel because I wouldn't get anything anyway. My view counts are not high enough to actually, give me any money. So what's the point? Why monetize it? And also because I hate ads, and so I don't want to subject you all to ads that you don't need to see. So if you want to watch all my content ad free, you can see my whole entire archive on YouTube. Do !YouTube if you want that link. And yeah, that's where you can watch my entire back catalog. I think we're up to a couple years of videos at this point. So we got projects for y'all if you want to flesh out your portfolio. Umton says, have you decided on what will be your next teaching topic after Python? Well, after we finish this course, we're going to do a project. The project I've been hinting at this entire time, where we're going to do some web scraping. And we're going to use that to build a full stack application. And we're going to take our web scrape data and we're going to essentially upload it into a SQL database. So we're going to take that web scrape data, we're going to format it into some kind of a CSV probably. And then we're going to take that, we're going to load it up into a Supabase SQL database, and then we're going to make sure that our application works as intended. Instinct says, side question, is there a playlist for SQL? There is, yes. It's not all inclusive of all of my SQL projects, but it's got my intro to SQL, like SQL for beginners type videos on it. Yeah. And then so after we do this Python, like real world Python project that I'm working on, it's a project I'm building for a local group I volunteer with. After we do that, so that'll be a mixture of Python, SQL, and full stack like JavaScript web development. So I think that'll be a pretty great sort of a combination of skills that we're going to kind of work through together. After that, we'll probably go back to kind of 100 devs, MERN stack content. So, MongoDB, Express, Node, React, that type of thing. We'll do that probably for a little bit, kind of go back to basics. And then I don't know what we'll do next. Maybe we'll learn Vue or something like that. Who knows? Haven't really thought that far ahead. Never do. But, whatever we do, it should be fun. Dan says, have you been able to play with NumPy or pandas yet? Can't recall if I asked before. I have used pandas in the past, the first time I tried to use Python. I do plan to play with that. I don't know if I'll do it on stream. If there's enough interest, then I might. Essentially what those are is more of like data analytics. So more for like what I do for my day job. Well, not necessarily anymore, but when I used to do data, and I used to be a data analyst for my full-time job, where you're really kind of taking the output from systems and, crunching that data. But I do think, I do less in my day job now where I'm a data engineer. I do a lot less data analytics than I did when I was an actual data analyst. Now my job is more focused on curating that data and serving it to the people who are doing the analytics. Like I'm just making sure that the data is flowing and that it's well formatted, and then it gets shown to the analysts to do the work. I might play with that. I don't know if I'll do it on stream or if it'll be more of a, side thing. We'll see. Jupyter notebooks are hella cool. Yeah, I've seen a lot of analysts using those. All right. But yeah, I think after this Python stretch and we apply the Python to the real project, after a long series like this, like I did the same thing after my React series, I kind of want to circle back around to basics and pick up some of those, beginning 100 devs viewers, people who are just starting 100 devs. We're going to kind of circle back, pick up some of those folks, give them some assistance with what they're working through, and then, build back up again to another sort of out there kind of a framework or something like that. So, I don't want to lose my base, which is, the folks who are in 100 devs. So got to circle back to basics occasionally, which I think is good, right? To practice those types of things. You don't want to get so far out there that you forget how to do the basic stuff. Mini Laravel. Yeah, I think actually Leah T Codes has been working in Laravel for a while. Yeah, and we might do that. Okay. Yeah, so if you're interested in learning Laravel, Leah T Codes is a great person to follow. They've been streaming pretty regularly. Well, give them a quick shout out. Never a bad time. Shout out Leah T Codes. There we go. So yeah, if you're interested in picking up Laravel, seeing that applied to a real project, give them a follow. Also, they're pretty great. They're part of the 100 Dev stream team, just like I am. And yeah, they do good work. All right, I've got the raid page pulled up here. So we can take a look and see if we can find somebody to raid. Also, feel free to, ask any remaining questions that you might have or topics or whatever. Happy to answer. As always, we're gonna look for somebody who's a similar or smaller size and in the same category, like to show the love to the small folks who are just getting started, because oftentimes they're doing the coolest projects. Okay. Armored Core clone in Godot. Wow. Hey, thanks, Dan. It was always great to see you. Dev and showing chat how to press buttons. Oh, this might be a Twitch bot. We just rated them. They were fun, but we just rated them, I think, like last time. Snake Studio Dev Time, Unity 6. Advent of Code. We got somebody doing Advent of Code here. Of course, Maiva. Cran says, I did not know you could do this in the Twitch Stream Manager. Yeah, it's pretty nice, actually. Yeah, I'm just in Stream Manager. If you're a streamer, I'm just in Stream Manager here, and they've added these nice filters here where you can, filter to specific categories. You can look for someone specific. It's pretty nifty. It's a fairly new thing that they've done to make this better. See, MIDI automation. Yeah, and by the way, yeah, Maiva brings up a great point. Have a happy New Year, folks. The next time I see you all, it should be after. Yeah, it's not going to be until the 5th. So, yeah, absolutely. Oh, we got somebody else doing Python here. Let's see what this person's up to. Oh, looks like they're doing some Python challenge problems. Yeah. Y'all can see if you can apply the Python skills that you picked up so far to help this person do some coding challenges in Python. Crayon says, I have a lot of not so positive opinions about Twitch, but I got to admit that they've really improved their built in streamer tools. I would agree. Yeah, I think once they finally started getting some competition from like Kick and other platforms, that they finally had to be like, they finally had to like pay attention to the streamer experience and actually make things user friendly a little bit. So yeah, I think they got a little bit of a little bit of the fear of God scared into them and be like, oh crap, we have to make things better for the people that use our platform. So yes, I would agree. The experience has gotten better in the past year or so. Yeah. Alrighty, folks, let's read this person. Alienated labor. Hey, Jujoko. Thank you so much, Mattel. Thank you so much, Jujoko. I hope everybody has a great new year. Let's raid this person. As always, please send them some positive vibes. Show them the same respect that you show me. And yeah, everybody have a great, happy new year. Let's raid indeed. Here we go. Alrighty, starting the raid now. Oh, I'm glad you like Severance, Laylo. Yes, new season's coming out January 17th, so be ready. Alrighty, folks. See ya. Bye-bye.